Welcome to this explainer. If you've been watching the tech space lately, you know we're standing right on the edge of a massive shift. We're moving away from the centralized cloud computing infrastructure we've relied on for over a decade, and we are stepping into something entirely new, a decentralized agent-native internet. Today, we're going to break down exactly how this transition is happening, layer by layer, and really explore the architecture of what is quickly becoming the machine economy. So, let's dive right in. So, picture this. How does an AI agent open a bank account? I mean, it sounds like the setup to a bad joke, right? But seriously, this is literally the most critical bottleneck in artificial intelligence today. We call it the agent problem. See, our legacy web infrastructure was brilliantly designed for humans who hold credit cards and who can easily pass Know Your Customer or KYC identity checks. But an autonomous AI agent, it obviously can't walk into a bank branch, it doesn't have a passport, and it definitely can't pull out a Visa card to pay for the server space it needs to think. Legacy systems make it practically impossible for autonomous AI to seamlessly transact and operate. All right, here is our roadmap for today. We'll start by looking at the AI compute crisis. Then we'll move into re-architecting the compute market, solving the verification problem, X402 for autonomous agents, demand-driven tokenomics and BMA, and finally, we'll bring it all together with the Agentic Web Stack. Okay, starting off with Section 1, the AI compute crisis. So what is the AI compute crisis? Basically, it's this severe mismatch between the sheer exponential demand for AI processing power and a totally bottlenecked GPU supply. You know, the demand curve is practically vertical right now, but the physical supply, it's artificially choked by just a handful of centralized tech giants who own all the big data centers. Leaning on these legacy cloud providers, it comes with some seriously crippling constraints. We're talking sky-high monopoly pricing because there's just so little competition at the top. If you're an AI startup, you often have to wait weeks for manual quota approvals just to get access to servers. And worse, they force these mandatory 8 GPU minimums on you. These legacy constraints are just bleeding innovative startups dry. It really proves that centralized systems simply can't scale at the speed or the granularity that modern AI actually needs. Moving on to Section 2, re-architecting the compute market. The fix here is DePIN, or Decentralized Physical Infrastructure Networks. Instead of building these massive, centralized, walled garden server warehouses, DePIN uses blockchain technology to coordinate and aggregate latent, real-world hardware from all across the globe. We are talking about tapping into the underutilized GPU power of independent data centers and even high-end gaming rigs just sitting idle in people's homes. It effectively turns the entire world into one giant, decentralized supercomputer. There's honestly a night and day difference between these two models. On the legacy side, you're dealing with monopolies, forced minimums, and strict KYC verification. But on the DePIN side, you get to tap into latent power with entirely permissionless access and massive cost savings. Projects out there right now like IO.net, Akash, and Nosana are already operational and offering anywhere from 35% to 86% cost savings compared to traditional clouds. It is a fundamental game changer in how compute resources are priced and accessed. Which brings us to Section 3, solving the verification problem. This introduces the idea of verifiable compute. Look, in a decentralized network, you can't just trust a brand name like AWS or Google. You have to trust the mathematics. Verifiable compute is the cryptographic proof that a specific calculation was executed flawlessly. It's the absolutely critical trust layer that entirely replaces the need for centralized corporate oversight. Let's geek out on the tech for a second, because the solutions here are actually fascinating. The first major challenge is that standard floating point math is non-associative. Basically, depending on the physical hardware, the exact same calculation can yield slightly different results at the microscopic decimal level. To fix this, protocols like Jensen's Verdi use reproducible operators, or RepOps, to guarantee bitwise reproducibility regardless of the chip. The second challenge? Verifying an entire AI training task is incredibly expensive and slow. The solution is Refereed Delegation. Think of it like a bisection game. Instead of checking everything, a referee system checks random checkpoint intervals. If a node is caught lying about its work, its staked tokens are aggressively slashed, so it keeps everyone totally honest through economic penalties and random spot checks. To sum up this technical hurdle, reproducible execution, or punarupadandogu yoksampadan, is absolutely non-negotiable. I really want to stress this core requirement. Without reproducible execution, trustless AI training across distributed global networks would be mathematically impossible. It is the absolute bedrock of the entire decentralized compute space. All right, Section 4, X402 for autonomous agents. The solution to how an agent actually pays for this verified compute is literally a piece of forgotten internet history. HTTP 402 payment required, or HTTP 402 payment prayogen. Decades ago, the founders of the web created this code right alongside the famous 404 not found error. But 402 was largely forgotten because the infrastructure for digital micropayments just didn't exist back then. Well, today, that standard is being revived. It is the perfect internet standard code to enable seamless machine-to-machine payments for APIs. Let's walk through exactly how this automated handshake plays out. It's a brilliant stand-in for a human typing in a credit card. Step 1. The AI agent sends a standard GET request to a server for some data or compute. Step 2. The server blocks it, issuing a challenge by returning an HTTP 402 code along with the pricing terms, the blockchain to use, and a receiving address. Step 3. The agent provides authorization by cryptographically signing a gasless payload. And finally, Step 4. Settlement. A facilitator submits this transaction to the network, and the server instantly delivers the requested resource to the agent. No human intervention required whatsoever. Now, during that third authorization step, you might be wondering, wait, where does the money actually come from? The agent uses a non-custodial wallet or non-custodial wallet. This is a wallet provided by infrastructure like Circle or Coinbase, where the autonomous agent itself holds the private keys. Not a bank, not a human proxy. The machine literally owns the capital. It signs an EIP 712 or 3009 payload, completely bypassing legacy financial systems to pay for its own existence. Moving on to Section 5, Demand-Driven Tokenomics and BME. Enter the Burn and Mint Equilibrium, or BME, Burn and Mint Equilibrium. This is an economic model where real-world usage literally destroys tokens to create deflationary value. Here's the absolute brilliance of BME. In networks like Akash, users burn volatile utility tokens like the AKT token to mint non-transferable USD-pegged ACT credits. This incredible mechanism ties the token's value directly to actual demand and network usage, rather than just wild market speculation and hype. All of this feeds into what we call the DePIN flywheel. Think of it like a massive economic engine. It starts with token incentives attracting hardware suppliers. This sudden surge in global supply aggressively drops compute costs. Those lower costs naturally attract more users and AI developers. And as we just learned, that real usage burns tokens, driving up the value of the ecosystem, which then attracts even more hardware. It's a beautiful, self-sustaining loop. When you pair this with systems like IO.net's incentive dynamic engine, it makes decentralized pricing just as predictable as traditional centralized clouds. And the lifeblood pumping through this whole economic flywheel? Stablecoin nanopayments. We're talking about tiny, fractional cent payments made in digital dollars like USDC or USDT. Because Asians don't need to pay monthly subscriptions, you know? Using stablecoin nanopayments, they can stream payments for compute resources literally by the second, paying only for exactly what they consume. Finally, Section 6, the Agentic Web Stack. So here is the progressive stack we've just built together today. Down at the base, you have the settlement layer powered by blockchain, ensuring trustless, decentralized ledgers. Right above that is the facilitation layer, using the X402 protocol so machines can actually transact. Then the coordination layer, using frameworks like MCP to logically organize tasks. And finally, sitting at the very top, the agent layer, powered by large language models. This is a completely new agent-native pyramid. We call this whole unified architecture the Agentic Web Stack. These are the 4 essential layers required for AI agents to break out of their chat boxes and operate fully autonomously out there in the real world. This stack is the definitive solution to that core problem we started with. It allows machines to finally navigate and transact on a web that was previously walled off for humans only. I want to leave you with this final thought. The future isn't just faster models. It's an internet where machine intelligence is a globally distributed, programmable commodity. Just pause and think about what that means for your daily life. When compute is decentralized, verifiable, and freely tradable by autonomous agents, the internet stops being a place we visit and becomes an intelligent engine that works for us. Thanks for joining me for this explainer, and keep learning.